Okay, hello friends. So the problem is a person of mass MP 80 kg climb a ladder of length L is equal to 5 meter and mass 15 kg. The ladder is propped against the smooth wall, making the angle theta is equal to 50 degree with the horizontal. At the ground, there is a static friction coefficient of mu is equal to zero point 4 and compute the maximum height of worker before ladder slip. Okay, so in problem there is a given mass of the person which is 80 kg, mass of the ladder it is 15 kg, length of the ladder is 5 meter and theta which is angle made by ladder with horizontal ground theta is equal to 50 degree, and we have to find what is the height person can reach before the ladder is slip. So let's assume say person will reach at maximum height x. Okay, so above the x height the ladder will slip. Okay, so now for this equilibrium condition force body diagram, so sum of the forces in x direction is equal to 0 and sum of the forces in y direction also is equal to 0, and sum of the torque about any point also need to be 0. So now this is our x direction, this is our y direction, this is x and y. So let's say what are the forces acting on y direction. So what are the forces in y direction? So first weight force of the ladder which is mlg. Second, weight of the person which is mpg, and there is a normal force by the ground on the ladder which is in this direction. So there is no other any y directional force since there is no friction, so if friction is 0 between this wall and ladder, because it is given that is the smooth wall which is given, there is the smooth wall, this smooth wall. So the total force is in y direction which is n, let's say it is n1, and these two force in opposite direction, so let's say it is minus mlg minus mpg and is equal to 0 because of the total force in y direction are 0. So n1 is equal to g ml plus mp, right? Now again second is total force in x direction is also 0. So what are the forces in x direction? So one force it is friction force by the ground, so which is in this direction, let's say it fs, and second is normal force by the wall on the ladder which is, let's say it is n2. So there is no other force in x direction, so and the direction of these two force is opposite, so fs minus n2 is equal to 0, so fs is equal to n2. Now third condition, total torque is 0 about any point. Let's consider this point, the point of contact on ladder and ground, let's say about this point. So what are the torque? First there is torque generated by the weight of the ladder, so let's say this component which is cos component of weight which is perpendicular to the ladder, and second is weight by the person, so this way cos component of person weight which is also perpendicular to the ladder. So and what is the this length? It is center of mass of the ladder at L by 2, and this length of the person reaches maximum height is x. So torque is first ml g cos theta into length at center of mass is L by 2 plus mp g cos theta, and the height at person reach is x, and which is balanced by this n2 force, the torque generated by n2. So what are torque generated by n2? So n2 have two component, one is along this ladder direction and one is perpendicular to it. Now this is your theta, so this component is sin theta, so it is n2 sin theta, and it is end of the ladder, so the total length from this to this, so it is L. So we got the equation mlg cos theta into L by 2 plus mpg cos theta into x is equal to n2 sin theta L. Now what is the n2? We have to find n2. N2 is equal to what? So here from this equation we know the friction force is equal to n2. So friction force, what is the friction force at this here? So friction force, as we know, it is given by mu into n. Here n is a n1, its normal component. So friction force is equal to mu into n1, and n1 is given here. N1 is this component. So n1 is equal to ml plus mp into g. It is mu g ml plus mp. Now if we put this value of fs, and fs is equal to n2. Now putting this n2 value in this equation, we will get equation, it is ml g cos theta into L by 2 plus mp g cos theta x is equal to n2 is equal to mu g ml plus mass of the person into L. Now from this equation we have to find what is the value of x. So it is mpg cos theta is equal to m is equal to mu g ml plus mp L. So here sin theta it's remaining, so it is sin theta minus ml g cos theta L by 2. Okay, g is common in all, so it is into x. So x is equal to mu ml plus mp L sin theta minus mlg, sorry, g is not here, g is cancelled, g cos theta L by 2 divided by mp into cos theta. So this equation, theta is given, ml is given, mp also given, L is given, and mu is also given. By putting all the value, you will get x is equal to 2.36 meter. So the ladder will slip before the person reach midway of this ladder. So it is around here. Before person reach here, the ladder will slip. Okay, so thank you.